let's look at our next question. So the next question that I have here says I must use the graph again. They're not telling me, we all know Planck's constant, but use the graph, and we must find Planck's constant. Now this one is very easy. I want to take it back to where I initially started. Remember, when we use the linear graph, we use y is equal to mx plus c. The value of m is exactly under h, which is my constant. Now I can see that h, or in terms of m, is delta y over delta x by finding 2 points. So I'm going to use exactly that, my darlings. I'm going to take it from the top though, 11.3.2. You must show the examiner. Let me see how many marks was this question actually going for. So this question was going for 4 marks, so that is a lot of marks. Now, if the question is for 4 marks, you actually get a mark for actually giving the formula as well. So show the examiners that you're saying y is equal to mx plus c. Remember, there's probably also more than one way of doing this. And I know when I'm looking for m, it's also my h. So I can say if I'm looking for m, I have delta y over delta x. And then I can say the value of y in that formula was representing my kinetic energy. And for y, it was representing my lambda. It was representing my lambda. So now I have to just plug in. I can take 2 points here, take 2 points from what you were given, because remember it says change. I just want to include this. Remember when we were doing physics, when we were doing momentum, vertical, projectile, and it says change in, then you have final velocity minus initial velocity and so forth. So there's always 2 variables that we have to work with. In this case, you choose 2 points from the table that you were given. So now we have, this is what we have. So I just took 2 points. I took the first 2 actually, and the first one. So I've got 6.6 times 10 to the negative 19. That was my kinetic energy for my first point. I know that the first point's lambda is 5, but my initial wavelength was the 6, and they were both times 10 to the negative 6 as per expression given. If you were to put this in your calculator, remember your brackets, you find 1.941 times 10 to the negative 25. Now remember, we're going to say Jm. But we are not done. Remember, if you're looking for h, now we have to say, according to h, we have to use the gradient. We have to use the gradient, and our gradient we just got. How did we find the gradient? By saying change in y is over to change in x. But in order to find Planck's constant, we say h is equal to gradient over the speed of light, which is a c. Remember, it is a small c, not a capital C. A small c, a capital C means Coulomb. So the gradient that I got was 1.941 multiplied by 10 to the negative 25. The speed of light is a constant. You do find it in your formula sheet, which is 3 times 10 to the exponent 8. Now, if you put this in your calculator, you'll find the h. Now, we are just confirming. I find 6.47 times 10 to the negative 34, and that is Js. Remember, this is Planck's constant. They do give it to us as 6.63 times 10 to the negative 4, but because we are using points, they will give you a bracket of being wrong or being right. But what is important with this is to take 2 points that you can use. Now, it really doesn't matter, but a trick or a rule of thumb I've actually learned, if you take 2 points most furthest apart, then you are most likely to get the most accurate answer. So for example, this means for this table here, if you were to use these points and these points, they are the most furthest apart, then you are more likely to get the correct answer. So it really doesn't matter, but rule of thumb always says or tells us that.